Now this last day of section 2.2, we're basically going to do one thing, but in doing that, first thing is make an appropriate graph to determine if a distribution is bell-shaped. We're going to use a 68, 95, 99.7 rule to assess normality of a data set. And then last is interpret a normal probability plot. Ultimately, we're going to learn today how can you tell if your data set has a truly normal distribution such that you can use the methods we learned in this chapter. On the first part of your day 5 notes, it's going to say how do you assess normality, and it's basically these two checkpoints here. What you ultimately want to do to see if the data set you have has a normal pattern to it, basically, so you can use this normal curve, is first plot the data. Make a dot plot, stem plot, or histogram to see if the graph is approximately symmetric and bell-shaped. If it is, then that's kind of your next step to go ahead and do the second step. But if it's not, if you notice that it clearly is skewed, or if you notice that it isn't bell-shaped, or if it has multiple peaks to it, so it's not unimodal. Any of these three components are going to tell you that this is evidence that your data is not normal. And then you should not be using any of the normal curve assumptions that we've been doing. But if you look at it and it looks fine, then you go to step 2. And what that is you check if the data follows the pattern of the 68, 95, 99.7 rule. And all you do is what it says here. You're basically just counting observations and coming up with a percent. You want to go within one standard deviation of the mean and count how many pieces of data fall within that range. And come up with a percent. If it's approximately 68%, then go within 2 standard deviations. Come up with a count to get a percent and see if it's around 95. And then wrap up with going about 3 standard deviations, count and come up with a percent. And this in itself will give you an idea if your data meets these rules, then it is probably normally distributed. Now, I only have one example in my notes where I walk through actually checking the data for this rule. It's the very last example about the 20 students. Again, this is the only thing that's truly within the scope of the AP exam, so if you want to jump right to that, you can. Other than that, I'm going to go talk about a probability plot next and show you 2 examples of the plot, and then I will wrap up with going through again the details on the 68, 95, 99.7 rule. Now the other thing the notes ask is how do you determine or interpret a normal probability plot? This right here is a normal probability plot, and it's not within the AP exam scope and that you're not going to be tested on it. But the AP board says you are welcome to use this method if you want to. What you do is you're basically going to take a histogram of the data or a dot plot of the data, and you're going to graph it in terms of an XY ordered plane. And how you graph it is down here, you put the same data set. So this here is survival time and this is survival time. What you do is you're going to convert your data to z-scores. And I'm going to show you on the last slide on how to do that. Now, how can you tell? What you're looking for is if points lie close to a straight line. If you can draw a linear pattern through these dots, then you know it probably is a normal curve. But if you can't, then it's telling you that the data is either skewed left or skewed right. Now in this data set, for example, if I draw kind of the line of best fit concept, it's probably going to be something of that nature. You can tell most of the data or more of the data is kind of coming out here on this side of it. This would indicate that it's going to be skewed right. You can tell by the histogram here, if you follow kind of a curvature pattern, it clearly is skewed right. And that's how you see it in a probability plot. So if you look in the notes, I have 3 examples. This is just a quick one. Here again is the current histogram that we have. And this is data about free throw percentages. Now what they've done is we can tell that this graph looks like it's somewhat probably skewed to the left. And you're going to notice they look at the probability plot already given for them. What you're seeing here is the same variable here and the same variable here. What this is are the z-scores for all the data. And again, let's just first talk about the interpretation of this plot. They drew a line here, and you can tell more of the data is to the left of it. Therefore, it's skewed left, and that's what we see, and it's not symmetric. Now, this next example, again, we look at the histogram, and it seems pretty clear that it is fairly skewed to the right. Well, here's the probability plot this time, and if you draw kind of the linear pattern for it, you're going to have something of this nature, and again, you're going to see most of the data points are going to be on the right-hand side for that one also. Now this is the last one, and I want to show you actually how you create the probability plot. Again, you are not going to be required to do this at all in the AP exam, but it's something that you're welcome to do if you want to test for normality. What you want to do is, what we could do actually, is put this data into stat edit. So I would go stat edit and put this in list 1. You could then take that and create a histogram under stat plot if you wanted to, or you could do a histogram by hand. Now you're going to notice I've already entered the data in the calculator under list 1. Now what we need to have is we're going to take the same data points are going to be on the x-axis here, but the y-axis is the z-score related to each data point. So in the calculator, I'm in list 2, I compute the z-score. And here's how you can do that fairly easily. I went into my list 1 and I did a one variable stat on it. The one variable stat came back and it said that the mean of my data set of this sample was 42.75. It said the standard deviation of my sample was 4.153. Now remember, to do a z-score, I'm going to take my piece of data, subtract the mean, and divide by standard deviation. So what I did is I went to list 2, and notice how I'm at the top here. I went up to list 2 and I just typed in a little formula down here. I said take list 1 and subtract 42.75 and then divide by, you just can't see because I got cut off, 4.153. And then I hit enter. When I did that, it populated all of the z-scores in here for me. So now I have like a nice XY ordered pair. So then I went into my stat plot and I chose to do a scatter plot. I chose list 1 and list 2. I then went into zoom stats, which is zoom number 9, and it zoomed into my statistics and gave me this graph right here. This is my probability plot, and you can tell there's definitely a linear pattern. I can draw a line such that it pretty much goes through every point on there, which tells me this data has a normal distribution to it. Okay. The other thing you can do, though, is what would you do, because this isn't in the scope of the AP exam, what would you do mathematically? Well, here's what you do. We're going to take this data right here, and I'm going to go to the next slide. So you're going to apply the 68, 95, 99.7 rule. So I'm going to do the 68% rule, which goes one standard deviation away. So what I'm going to do is I'm going to take the mean, and I'm going to add to it and subtract from it in two different calcs, one standard deviation. When I do that, I'm going to get a range that the mean is going to be between 38.597 to 46.9. Now, I go back to my data set of, I had in here 20 pieces of data, and I count all the pieces of the data that are in this range. There's 15. So 15 of the 20 is 75%. So I'm assessing is 75% fairly close to 68% for normality. It seems okay. It's not bad. So let's go on and test 95%. Does 95% of my data sit within 2 standard deviations? Well, I take the mean, and now I add and subtract 2 of the standard deviations. And now the new acceptable range goes from 34.44 to 51.56. I count all the pieces of data, and there's 19 that make it. 19 over 20 is 95%. So in terms of 2 standard deviations, it's spot on. I'm going to check the 3 standard deviations for 99.7%. Take the mean. And that's going to give me an acceptable range of data. And I count and I notice it's all my pieces of data. So 20 of the 20 make it, and 100% of my data is within 3 standard deviations, when normality would say 99.7 is. Based on these statistics, you could assume that we do have a normal distribution. Also, looking at that probability plot, we should feel very comfortable that this data is normally distributed, therefore we could use the normal curve logic in answering various questions about it.